Alright, in this video we're going to take care of some sound system setup. We're going to be looking at a few different things, first of which is the sound engine. We're going to get the sound engines which we had coded in earlier projects and then imported into the drum game. We're going to get those fully linked up and ready to go.
Okay.
We're also going to handle sound engine configuration. We're actually going to allow the specific sound engine to be selected by a setting in the config file. And we will also be taking a look at getting some sounds loaded. And the sounds themselves will also be configurable.
So, I'm sorry.
But we'll address those as tracks once we get the sound engine set up.
Okay, so when this is all done, will we be able to try out our game and have sounds play?
Yep, we'll be able to try the kind of the way we've been doing simple debug inputs. We'll actually bind those up to the notes in question and play sounds based on those notes.
Well, let's get rolling.
All right, first up is the sound engine setting in the configuration file. Here we're already looking at config.xml, so I'm going to jump up to the top underneath the options section, and we'll drop down a new option. This will be a node called sound engine, and we'll give it a single attribute called value, and we'll set that attribute to, in this case, we'll begin with exact. So we could basically have exact or direct sound in this case. But we'll see the available options when we get to the other side of this, which is the configuration inside of the config class.
Gotcha. But in the end, what's going to happen is this value will change depending on which sound engine you want to use?
That's right. If we take a minute to go here into the Solution Explorer, we can go down to our sound engines, where we have sound engine direct sound and sound engine exact.
Okay.
So this will be a setting that will allow us to select one of these engines. Now let's go and jump into the config.cs file down here in our configuration class. Let's actually jump up here right below load input, and we'll make a new method called load sound. It'll be a public static method, no return, and the method name again is load sound. And load sound will take in a game instance. So we'll take in a game parameter called game. Now inside of load sound we're going to be doing two things. First, we're going to select and then initialize a specific sound engine, and then we're going to turn around and load a bunch of sounds into that sound engine to get them ready to play.
Okay.
So let's begin with the first part, getting the sound engine set up and initialized. The first thing in here we'll do is we'll make a variable called sound engine name, and we'll load up the setting in the config XML file. So we'll make a string here, sound engine name, and we'll set that to the setting we just created in the XML file. We'll use the getNodeValue method in order to load that value out. So we can use our previously coded getNodeValue. We need to pass in the XML document that we're using, and that is the XML config instance. And the node path is simply going to be the absolute path to the sound engine, which just for visual reference means we need to look at config/options/sound engine. So here we'll do /config/options/sound engine. So finish off the string here, finish off the closing parenthesis, then we should have our sound engine setting loaded into a local variable. Now we'll do a few checks on that setting and see if we need to load up a direct sound engine or an exact sound engine. And for this we'll use a simple if statement.
Okay.
So we'll say if sound engine name is equal to direct sound, then we'll load up a sound engine direct sound. Now when we say load up a sound engine, what we're actually meaning is instantiate a new sound engine and store that instance into the global state.soundEngine value. If you remember, of course, up here in global state, we have a series of fields, and one of those fields is the sound engine that our game is going to use.
Yeah, it's been a little while since we've seen that, so good review.
Also, I'm going to close out this buttons class that we looked at earlier. We'll close it out to give ourselves a little bit more room to work with. Alright, back to our config class. So now we know where we're going to be looking, so we'll address global state, and we'll set the sound engine to be equal to a new instance of sound engine direct sound. Now, if we didn't find a direct sound, or rather if the setting was not set to direct sound, then we'll check and see if it was set to exact. So we'll do an else if statement. So else if sound engine was equal to exact, then we'll turn around and load up an exact sound engine. So global state.sound engine equal to new sound engine exact.
It's pretty straightforward.
Now, if the sound engine setting was not set to direct sound and it was not set to exact, we want to load up a sound engine. We need to load up a sound engine because later on the game is going to be playing sounds, and if global state.sound engine remains null, that means we'll crash our game as soon as we go to play a sound.
Okay.
So in the event that we had an invalid setting for sound engine, we want to make sure that we do instantiate a sound engine to satisfy any calls to play sound, but we don't want anything to actually happen since we haven't described how. And if you remember when we were bringing the sound engines into the drum game, we also added a new sound engine called sound engine null, and its purpose was a sound engine that satisfied the method interface for a sound engine, but it did nothing.
Okay.
So you can run a call to play sound, but nothing happens.
So here we're basically going to be checking to see if they've entered direct sound or exact, and if it's anything else, we're just going to load up sound engine null.
Exactly. You could look at that as your default sound engine.
Right.
It doesn't do anything.
Actually, I'd call it more of a fallback.
You could, yeah.
Because default would be something that might actually work, or at least I'd hope the defaults would work.
Right, so this is a fallback so that if the sound engine configuration is messed up, the game won't play sound, but it also won't crash.
Okay.
So we'll do this here by adding an else clause to our if statement. So if we were not looking at direct sound and we were not looking at exact, then we'll go in here and we'll say that global state.soundEngine will be set to a new instance of sound engine null. Then, just to make it a little bit more obvious that something isn't quite right, we'll also write out to our log. So log write line, and we'll say that there was an invalid audio engine specified. Just to make it clear that something was configured incorrectly. Alright, now that we have a sound engine selected, we need to turn around and initialize that sound engine. So as soon as we're done with our if statement, we'll look back into global state and we'll tell the current sound engine instance to initialize. And that call to initialize is going to require a game instance, so we'll pass in the game parameter that was given to load sound. And that should take care of getting our sound engine all set up.
Okay.
Now once the sound engine is loaded, we're going to show that as well, just to make it clear for debugging purposes what sound engine is being used. We'll show that to the log as well. So we'll do another log.writeLine call, and we'll say something like sound engine, and that sound engine is going to be described by argument 0, finish off the format string, and then drop in global state dot sound engine dot toString, just to explicitly say, tell the class just to describe itself. Alright, with that, let's briefly turn our attention to the game class so that we can get our sound engine field linked up to the game, because we need to make sure certain things happen, like 1, load sound gets called at all. 2, we need to make sure that any necessary update or unload calls get passed on to the current sound engine to satisfy the inner workings of the actual sound engine classes. So we'll jump over here to game, and we'll first visit the constructor. So here up at the top, we'll jump in right after we do config.loadInput. We'll turn around and do config.loadSound. course, load sound is going to need the current instance of the game, so we'll pass that using this reference. Alright, the next thing to address is we'll make sure that the sound engine is getting unloaded. So we'll scroll down here to right above update. We have the unload content method. We're already disposing of the fill texture, so we'll drop in a line below. We'll look at global state, and we'll tell the sound engine to unload. And then one last thing we need to do is make sure that inside of update, that we pass along update calls to the sound engine so that it can continue functioning. Global state.soundengine.update.
So at this point we have a sound engine that should technically be loading up, but we don't have any sounds to play, right?
That's right. As a matter of fact, we should be able to run the game at this point. And we can see here at the bottom that we have sound engine currently set to sound engine exact.
Very nice.
And we can play around with the setting a little bit just to make sure that it is loading properly. We could change this out to direct sound. We can see that. That appears to also be a valid sound engine, and it's showing us sound engine direct sound.
What if you set it to cat?
I don't know. Let's try. If we set the engine to cat, we should get invalid audio engine specified.
Nice.
Then the actual audio engine in use is currently sound engine null.
Very nice.
So we can tell that our fallback is indeed working. So let's set this back to exact. We'll use that for the purposes of testing the game. And now we can turn our attention to the individual sounds. Because at this point, if we look here in the config class, we've got, if we scroll down to, here we are at load sound, we've got the sound engine set up. But if you remember, we need to now load sounds into that sound engine to make them available for play. So that means we're going to need some way to look at all of the sounds. We'll use the ones here in samples as a reference.
Okay.
So basically we need to get everything in here loaded into the sound engine. Now we're going to need to do more than just look at sounds. When we actually get into the game, we're going to have a rendering system. That rendering system is going to allow us to place visual notes onto a form of musical staff, a kind of hybrid between game display and music display.
Right.
And that staff is going to have things like little dot markers to represent the notes themselves. Those notes are going to be color-coded per track, per drum track, and we're also going to list the name of the specific drum track off to the side of the screen, so it'll be very obvious what's happening inside the game.
Okay.
Now, we need to come up with some way of storing and configuring all of that information. A way to say that, okay, we have tracks, and we have a certain number of them, that they have names, sounds, and colors. So the way we're going to do that is here inside of the config XML file, we are going to make a new section. Right here under options, we're going to make a section called tracks. And into tracks, we're going to add any number of track nodes. So just as an example, we can begin with the first one. We'll drop in a node called track, and into this node we're going to add 3 attributes. We'll add a name, a sound, and a color.
Okay.
And this will allow us to store and associate all of this information.
So the name is what they're going to see on the screen when you actually label each track. The sound will be the actual sound file we're looking for, and color will be whatever color we decide to apply to that note.
Exactly.
Okay.
So for the very first track, we're going to set that to be the crash sound. So the name, the visual name will be crash. The sound will be crash.wave, since we're going to need to link these up so that all the sound engines can load the full sound. And if you remember, when we put the sound engine direct sound into action, it required a full path to the direct wave file. So that means in this case the sound is actually going to need to be crash.wave. And finally we're going to have a color for the notes on this track, and we'll specify that using the same format as we did in the style configuration, where we just used the red, green, and blue values separated by commas.
Right, so we can parse it out the same way later.
So in this case, we've got a set of colors we've prepared for using with notes, and the crash track color is going to be a value of 126 in red, 236 in green, and 141 in blue.
Okay.
So we'll have more of a greenish color. Then we can end off that node, And that is an example of a single track. And the idea is that we simply add as many tracks as we wish to have inside of the game. So I'm going to copy the crash track, and we'll use that as our template.
Mm-hmm.
And then we'll paste it in probably 7 more times. So going down the list, we have hi-hat, followed by snare, followed by
Tom's
tom1.
Tom _1 _2 and _3.
So toms 1, 2, and 3.
So you can do space 1.
Yeah, I think we'll change it up a little bit.
Okay.
We can put, in this case, since everything is configured by attribute here,
Yeah.
we're not really restricted on what we put in place, so we'll just do toms 1, 2, and 3.
And then kick and ride.
So kick and ride, we'll fill out our final 2 tracks. And now we need to also link up associated sounds for these. Hi-hat is, of course, if we look through here and match up all of our sounds, that's hi-hat.wave, followed by snare.wave.
And these are tom high, tom mid, and then tom low.
So tom high, tom mid, and grab just a bit of spelling, followed by tom low.
And then kick and ride. So now you just need to clean up the colors.
So now we need to go through all of the various colors. And again, these were values simply prepared to separate each track.
I'll read them off for you if you like.
All right, beginning with hi-hat,
Yeah.
element red.
246. Green will be 226. Blue will be 111.
All right, next up we've got snare.
246 red. 116 green. 131 blue.
All right, takes care of snare.
236 red for tom 1. 126 green. 221 blue. For tom 2, you have 126 red. 126 green. 251 blue. For tom low, you have 126 red.
Yep.
And then 236 green.
Yep.
141 blue.
All right.
For kick, 236 red, 166 green, 111 blue. And then for the last one, ride, you have 126 red, 126 green, and 251 blue.
All right, so it takes care of a handful of colors. And for exactly what those colors look like, well, I'm afraid you'll just have to wait until we get into the rendering section.
You're going to clean up the formatting on that?
We could. Let's go here with the
Do it
names.
for consistency.
And just give ourselves some nice, evenly aligned columns. Very nice. All right, let's turn our attention now back to the configuration class. And we'll come up with some data types to store this information. As a matter of fact, the main pieces of information that we'll need to store will be a list of names to be referenced later and a list of colors to be referenced later.
Okay.
Now, we're not actually going to create a list of sounds. The reason we're not going to do this is because these names will be loaded directly into the sound engine, and then the sound engine itself is already set up to be able to play sounds by index.
Mm-hmm.
That does mean that the order in which we enter tracks into the track section is important. That means the first entry will always appear as the top track, and the last entry will always appear as the bottom track.
Okay.
And this also is what it's going to give us our index by which to play sounds. So that means index 0 will play the crash sound, and then finally, if we count all these out, which I believe ends in 7, we'll have the last one, which will play our ride sound.
All right.
So the idea is that instead of making a list of sounds, we just leverage the fact that the sound engine remembers the sounds that it had loaded.
Sure.
So, going over here into config, we do need to set up the ability to store names and colors. So up here in the fields section of our config class, we'll jump in, let's see, right below game maps, and we'll make 2 lists. The first one is going to contain the names, so it will be a string list. It will be both public and static. So we have here list of type string, and we're going to call this list track names. And we'll go ahead and instantiate the list. Then we'll turn around and do the exact same thing for track colors, and since most of it is the same series of modifiers, we'll just copy and paste the track names line. We'll change the name of it to track colors, and this means, of course, we want to change the type of the list to a color list and instantiate a new color list. So this takes care of the containers that will hold names and colors for our tracks. Now we can jump down here to load sound right after we get the sound engine initialization taken care of, and we can put together these tracks.
Okay.
The first thing we'll need to do is we'll need to loop through all of the track entries that are found here in the configuration file. And we'll do so in a manner that is similar to what we did when we looped through all of our input binding nodes. With one difference. In the input binding, we made sure that we grabbed absolutely everything, whether it was keybind nodes or gamepad bind nodes or anything. In the sound setup, we're going to grab only nodes that are named track.
Okay.
So what's interesting is we're going to provide what looks like an absolute path. The path will be config, tracks, and then track. Now what's interesting is even though that's an absolute path, it's referencing a section with multiple of the same name, which means if we use that in conjunction with select nodes instead of select single node, we'll actually get back multiple tracks. It'll load all of the names that happen to match, even if there's more than one. So that means back here in config, we're going to put together a list of these nodes. Instead of looping on them directly like we did here in the input section, I'm actually going to store these out to an actual node list.
Okay.
So in order to see the type that we're going to need to store into, let's first look at XML config, and let's run, or rather make a call to select nodes. And we'll pass in the path, which is /config /tracks /track. And then since we know the fact that we have multiple of these type of nodes, then we should get multiple returned back from select nodes. Now, of course, select nodes is going to be storing an XML node list type. So I'll make a local variable here of type XML node list. And we'll call this track nodes. So that's the actual variable that we'll store the node list into. Now we'll turn around and we'll make another local variable that we'll use for assembling the full path. Because, of course, in the config file here, we only have the name of the file itself. So in order to get that sound loaded into the sound engine, we'll need to resolve the absolute path. So we'll do that using a local variable here called string sound file. Alright, now that we've got our variables set up, we can turn around and create a loop so we can walk through all of our nodes. We'll make a for each loop, and we'll loop through nodes of type XML node. We'll call each individual variable node as we walk through them, and then we're looping through the collection called track nodes. So we loop through our XML node list. Now, as we're walking node by node, the first two values, the name and the color, are very easy. We simply grab that value out and store it into the respective list. So what we can do is we can say here track names dot add, and we'll add in the attribute off of this specific node. So if we look at the node at hand, the track that we're looking at, if we look into its attributes and then read an attribute named name, the value of that attribute should be the name of the track. So now we can take a look at, well, first off, closing the parenthesis to take care of our track names.add. Then I'll simply duplicate the track names line and change track names list to track colors, and we'll add the node attribute color. And that should take care of color. Although looking at one thing, the IntelliSense isn't happy with us here on account of some typing. With track names, value is a string, which stores nicely in a string list. Here, color, the value of color is still a string, and that does not store nicely in a color list. So let's use our parse color method to get that red in. So let's look through here. We have parse color. We'll take in that string and kick back an actual color value, which can be stored in the track colors list.
Okay.
All right, that takes care of name and color, and we have one last attribute, and that attribute is sound. We need to get that sound value resolved to a full file name, and then load that into the current sound engine. So for this, we'll use our sound file variable. We'll set that equal to path.combine. Basically, we're going to take the path called samples path that we've already resolved back here in global state. We, of course, have samples path. Then in the game's constructor, of course, we did all of our path expansion here. So now samples path should be the full path to samples. So we're going to need to look at path. And it looks like we don't yet have the path type available to us. And we can remedy that by very briefly going to the top of the config class and adding in a using for system.io. So now if we scroll back down to load sound, here at the bottom, path is now lit up, and we have access to the combine method. So we're going to combine two paths. First is going to be global state.samplesPath. And the second part is going to be the current sound value. So we'll look back into our current track node, look at its attributes, grab the attribute named sound, look at its value, and that sound value is what goes into the second part of our path.combine.
Gotcha.
So now that we've resolved a full path to an actual wave file, let's look at global state, look into the current sound engine, and tell the sound engine to load a sound. Now we're looking for sound name, which we'll patch into sound file. So now, if everything is working, we should have a loop set to read in all of our tracks. Their names, colors get stored, and the sounds get loaded into the sound engine.
Right. Now we're not utilizing the color information just yet because we have no rendering system.
That's right. Color information is going into the list to be used later.
Okay.
Now, one thing I do want to do before we step away from this code is let me set a breakpoint on the closing brace for the for each, and I just want to walk through a few of these tracks getting loaded in to make sure that everything is looking good.
Sure.
So we'll set a breakpoint here. We hit the breakpoint, so we know that we are, in fact, calling load sound.
Mm-hmm.
Well, if we look at our, let's take a look at track nodes. And our XML node list has 8 elements in it, so we've got 8 tracks there. So far with track names, we've loaded in crash, and we've loaded in a color, so we're getting values back on both of those. Sound file is resolving out to a full path, rendering in crash.wave.
Nice.
And the sound engine seems to have had no trouble loading in that sound.
Very cool.
So I'm going to set another breakpoint, this time on the closing brace for the overall load sound method.
Mm-hmm.
I'll remove the breakpoint here for our loop, so if I hit F5, we'll finish off all the remaining iterations of the loop.
Yeah.
But now we can look and see that track names has all of our names loaded in, track colors has all of our colors loaded in, and we should have sound engine now with all of the sounds put in place.
Most excellent.
So at this point, I'm going to hit Shift F5. We'll terminate this debug session, and now let's actually try this out. Let's go back to the game class, and let's jump down to our input handler, down here in input pressed. Since we've already got some notes bound up in the config file, we've got the Z through all the bottom row keys on our keyboard bound to different notes. So let's try actually playing those notes. I don't think we need our line to input data anymore, so we'll comment it out and probably take it out here in a minute. Let's instead turn our attention to the sound engine. As soon as we get input, let's look at global state, look into the sound engine, and tell it to play. And then we need the index of a track to play.
Which is going to be that data.
So we'll pass in input data.data.
Nice.
You'll notice that we're not even doing a check to see if we have a note. So that means things like the up and down buttons will also cause notes to play.
Gotcha.
This is just showing routing that data.
Well, it'll cause whatever's on note 0 to play, won't it?
That's right.
Yeah.
And let's see. just to show the rest of the information, let's add another log write line to also show data and color. So we'll put together a log.writeLine call. We'll make a simple format string where we just put argument 0 space argument 1. And then we'll feed in the input, the track name and color. Now, in order to resolve a track name here, that's a little bit interesting because here we've got input data coming in. Input data has data. Data can be used to address a track. Now, we need to use that in conjunction with the track names and track colors lists from config. So in order to grab the track name, we'd have to look into config.tracknames and grab the sub-element here of input data data. So that means if we got note 0, then we look up name 0. Now let's do the same thing for our track color. Let's grab config.trackColors and then simply plug in input data data. And then just to make this all fit within our editor here, I'll drop the last argument down onto its own line. There we go. So if we build at this point, we should be able to run the game, hit all of our various notes, and hear sounds.
All right.
So there we've got the crash.
Nice.
And the rest.
Very cool.
And you can see that as we were hitting different keys, we're getting the name of the drum in question along with its color printed as numbers.
Very cool. So now we've actually got the first part of the drum game actually in place. We can play drums.
Exactly. And at this point, we've just made a simple electronic drum kit.
Yep. Very nice. Well, is there anything else you want to cover in this video? Kind of drawn on for a little while, but we got a lot done.
But yeah, we've got a lot of stuff covered. I think that's going to wrap it up. Again, we started with sound engine configuration, got our sound engine initialized, all tied into the game. We've got the concept of tracks established, where tracks are various drum tracks. They have names, sounds, and colors. And we've stored all of the necessary information, got our sound engine loaded up so that we could actually play the associated sounds.
Okay. Well, that's going to wrap things up for this video then. Thanks a lot.